welcome everyone to August webinar. We're going to be talking about AI and how that's going to be affecting M&V. And I have with me Steve Kromer and Benedetto, how do I say this, Grillone? Grillone?
Grillone.
Grillone. And I am not going to introduce them. I'm not even going to try to introduce them. I'm going to have them introduce themselves. Steve, can you bring up the next slide? And I'm going to, I probably won't be interjecting since there's two of them, so I'm going to even have my picture go away and my audio. Go ahead, Steve and Benedetto.
Well, my name's Steve Kromer. I'm sitting in Maryland at my sister's house, and about 31 years ago, I was living in DC because I got dragged into writing M&V protocols, and I didn't know what M&V was. No one did. The federal government had just started something called performance contracting, and they needed a way to extend out to pay out for equipment through many years through the savings, the energy cost savings. Didn't have one, needed to bring everyone together in the US at that time to come up with a method that the government would accept. So we cobbled together something that we now call M&V 30 years later. Ever since then, I've been involved in one way or another in this measurement of absence of energy, quantifying the absence of energy, and certifying people and whatnot. That's me. A year or so ago, is doing this as part of Watt Carbon, and Watt Carbon being a carbon emissions reduction entity, where they give you credits for how much you've reduced. They needed an M&V protocol, and they have technical meetings. There's one today. I'm not at it, but I met Benedetto there, and we sort of mind melded right away. We just like finishing each other's sentences. I go, dude, I got to get to know you because you have 8 years experience in the university in AI, and we've had a lot of fun since then in various settings. So Benedetto.
Yeah, right. Thanks, Steve. Yeah, I'm, well, maybe a little bit about my background. So I'm originally Italian, but living in Spain now for a while. So on the other side of the ocean, I guess, compared to the rest of you attending this webinar. But yeah, I've been having a lot of fun with Steve lately. You could say that I accidentally ended up doing a PhD in M&V and like especially machine learning applied to M&V. I didn't even know exactly what it was because before I started doing it, but then yeah, just went with the flow and ended up doing a lot of work in this field, and of course a lot of work with IPMVP. And then at some point I just met Steve, who was like, yeah, I was there when we wrote IPMVP the first time in the 90s. And yeah, since then we've done a couple of webinars together, and we've been collaborating on some fun stuff. And yeah, really looking forward to the session today. I think we have some interesting things for everyone here.
So the title of this talk is, yeah, I mean, we all know now, if we're aware and listening anywhere, the AI is in all our tools. It's taking over. It's everywhere. What's AI? Well, it's really just smart computing, but we'll get into that. So we're being faced with adapting all of our lives around using these tools. That's great. And we're going to talk about the application of this in M&V. So what we're really going to focus on, I think, Benedetto, you and I agreed, is that the subtext of this whole talk is how do humans stay in the loop? How do humans have their hands on the wheel so they can drive these AI tools of all types? As I said this morning, I was trying to drive a lawnmower. I had to go learn the rules a little bit, but I did as a human to drive that thing safely. So John knows I like to play with words and push concepts. And when we formed IPMVP, I'll take some credit for naming it. And when we wrote the IPMVP document, we called it Concepts and Contexts. That was in a meeting one night in a board meeting. That sounds good. So I like to come up with new catchy terms. And the one I got now for this talk, actually, I'm going to call it Quantitative Counterfactual Analysis. And I'm going to suggest here that M&V is a subset of that. It's been the language we used, and particularly out of the federal government here 30 years ago that got promulgated for 30 years as IPMVP. But it started as serving the needs. The use case was performance contracting in the federal government. We got it mostly right. It's been good for 30 years. It's a subset of something I'm going to talk about next. So this quantitative counterfactual analysis asks, what would have happened without an intervention? A very general intervention. It can be any number of things. We'll talk about that in a second. But the result comes back in a quantity. and amounts. How much of something didn't happen? How can we agree on that amount between parties? So that's our general challenge within M&V, right? And then AI is just improving on every aspect of that when we're out in the real world. Our ability to define what we're doing in M&V plans, design and implement and communicate the counterfactual idea that we've come up with. Ultimately, before checks get written or incentives get paid or the value of the product of our work in energy management and carbon abatement, which is the absence of something, when the value of that needs to get transferred, humans need to agree on that. So we haven't put that in the blockchain yet. If we do, humans will agree on how to do that. Okay, so now let's see if okay, so let me just go a little bit. QCA. So quantitative is just numbers. Again, counterfactual is agreed upon design, the rules of the game. Counterfactual could be, what if I hadn't gone to this school? What if I hadn't gone to Virginia Tech? What would have happened? That's a story. Our lives are filled with counterfactuals. Almost everything we do and think about is in retrospect or in perspective with something we could have done. And we're always kind of gauging what happens compared to what we could have done. Maybe if we get into really Zen and John Vina does his meditation, we're comfortable. But otherwise, we're always wondering what we could have done. So,
hey,
yeah.
Steve, can I interrupt? So
Yeah.
counterfactual for us M&V people, that's just generally just baseline or adjusted baseline. It's how much energy would have been used. That's
right.
another word for counterfactual.
Right, and M&V, the subset, so I'll get to that in the next slide, why I think this is important. But counterfactual is a very general term about comparing what does happen in the future to what might happen. Quantitative means we take the action of saying, let's put that into numbers. So we're going to actually, within M&V, come up with a baseline model and run that model and then compare in numbers. And at the end, we have a result in amounts, right? Not if I hadn't gone out with that girl, I'd be going out with, or what's the storyline, but an amount of something. And so what we do is we design counterfactuals between ourselves in the option C or option A or different language. And then we analyze what happened. We don't measure the absence of energy. We analyze it by updating our counterfactual. Okay, so in our case, the QCAs, the quantitative counterfactual analysis structures energy impact results for a wide range of energy and carbon. It helps, and AI comes in now in our careers in the last 6 months, year, and helps automate that whole process. The modeling and the uncertainty analysis, if you do it, John, and aids in communication to build the trust between the humans. So again, the goal of all this and the access to all these tools ultimately has to be resolved between humans agreeing and writing checks and taking incentives and stuff. So AI has a number of different ways it can help to build trust between the parties that are going to get involved when we're doing energy and carbon management. The thing is, a lot of people around the world have the same issue. They're trying to quantify the impacts of interventions generally, and they need tools to do that. And they have two major types, statistical and physical. They're stuck with the same limited set of theoretical tools, but everyone's trying to use AI to figure that out. So I came up with this link, and I built this website myself. And shoot, I think it takes a second to load if I haven't loaded it lately. It's in Replit. In about 5 minutes, I created a website on causal and intervention-based conferences around the world. And all these we would go to and find people that you would talk to, and they're trying to do the same thing you are. They're trying to say, if I invent something or if I move something into the future, what would have happened if I hadn't done it? By how much? And they're all based on causal, which means they have physics models behind them. All right, so there's a lot of people doing this, and AI can help access them, and you want to know what they're doing. All right, so AI in M&V is, there's so many different ways you can use it. We all know you can do, you could build an M&V plan. You could get an RFP and review it quickly for what's in it, see what you need to do. There's a number of just fundamental administrative tasks now that AI is going to help with. I'm not going to have an example, but you've probably all seen it. You've run a chat. If not, go find an RFP and run it and say, give me the 3-sentence version of this, and it'll boil it down for you. You can respond to an RFP really quickly. You can come up with a draft RFP response. You can feed it your information and fill in all the stuff. It's amazing. It'll cut your workload to about 1/10 of what it used to be. You can train it on your library of previous work. There's ways of taking all your stuff, loading it in, either on DeepSeek on your computer, or if you trust the web or the internet, you can put it up and you can train all your tools. So even just the fundamental, the mundane, back and forth administration stuff starts to get interesting when we talk about structured data and the actual energy data, and you can extract from energy audits. You could pump energy audits into tools and extract all the data you need as your baseline, run your baseline models quickly and easily. Nameplates, schedules, all that kind of stuff. Take a picture of equipment, push a button, it'll come back with all the information. It's just, okay, amazing. And helps to visualize what I call counterfactual models, including the holy grail of our industry, if we ever get, when we get there, it's digital twins. So this, the clock is, this one is a link at Autodesk University. If you know about Autodesk, they run Revit. And there's a guy, Adam Musniks, I pronounced his wrong, probably name wrong, but this is a really, really great presentation he gave on improving operations of existing buildings using Autodesk Tandem and energy analysis to drive decarbonization. It's a way in which you use AI to take an initial building energy model in steps to make it to where it's really close to the actual building in terms of its performance. So I really highly recommend that, but this is not a time to go do that. But these are that's kind of the goal. How do we initialize these counterfactual models at very detailed levels? People
is that going to be an option? Does he use option D? Is that what that is?
Yeah, John, I'm trying to throw that term.
Okay.
But yes, fundamentally the goal.
That's all I'm going to hear. Yes.
At some point we go back to the history. Like option D got added later in the whole process of the protocols, because no one could figure out how to use energy models really effectively for M&V. Too expensive, they don't work very well. All that's getting solved in real time. You can use this Autodesk stuff, you can use the set metrics software that Adam came up with, and you can, sit back and watch the computer, calibrate your model on the data you have, and get a pretty darn good model in no time. And now there's no reason everyone doesn't have a model of their building, basically. There's just no reason. So it's just unbelievable how fast these tools are moving. So yeah, we used to call it option D. All that meant was that you're using a physical simulation model that could use physics, not statistics. Okay, I'm going to try and get through this so Benedetto has time. But the fact is, AI, again, the mundane tasks, the most extremely cool tasks, and of course you can generate graphics quickly. And here's something I built really quick to respond to audience types. So you find out in the sales and marketing world, John, you might know this, others, personas, right? When you're in an M&V, we all know this. When you're dealing with different people, whether it's procurement officers or finance types, they've all got their own language. So I created a tool in no time on M&V and on either Vercel or Replit, I don't know, one of these integrated development environments that you pay $20 a month for, and you can build these tools in like 10 minutes. And they say, I'll talk to whoever you want to talk to, and I will read them my book, The Role of the M&V Professional, in their language. So you can customize how you're going to talk to different audiences and communicate with them, on the same underlying information. Wow, isn't that cool? Like, I think that's one of the biggest impediments to important performance contracting in general. I'm going to interject there. There's a really great talk that this guy George Buchanan put on for AEE last week on Wednesday, and it was his experience in the FEMP program with M&V, and a lot of it got back to just the challenges of communication between all the people and making sure communication's updated and clear, and reporting and expectations are all set up, and that's taking into consideration the audience and their personas. Okay, cross-validating reports versus model expectations, just all that data analysis stuff. Translates technical outputs into readable content for digestion by whatever party you're working with. Can generate regulatory documentation whenever you need. If you know what the regulations are, you can generate it. Maps findings to program and code requirements. So if you have code requirements, which we all do, am I fitting those? Again, that's kind of the more general administrative. We go back to the technical. Howard Penrose came to my class on M&V once, and he showed me some of these really cool things like extracting performance data from spec sheets, analysis of field data versus performance, and this whole set of tools it can do. I actually came up with this expert advisor tool really quickly, where you can go to my book and start chatting with my dog. Wilson will tell you all about M&V, any question you have. I won't go into that. But I also threw in some if you want to show someone how regression works, this took about 10 seconds to build. And if you want someone to show someone an example, like I do training, here's an example of an M&V analysis. And if you want to open up the Excel spreadsheet and see what that exact data looks like in Excel, I can now navigate all my old Excel training stuff and put it up on the web, like this in no time, so that people get a sense of, you can do it on Excel, or you can do it in Scikit on this, or it's all the same underlying mathematics, right? So it should give people confidence. All right, reusable code. They can't even get into like all the various tools that are now. You can generate Python, R. You can do the most complex stuff, play with it, Bayesian analysis, generate the code, go home and run it on your own computer. It works. Rapid development of the bots, like I just showed you. Rapid development of websites, like I just showed you, and can create custom M&V tools. I didn't show you that, but I'm working on one for energy modeling right now. M&V plan tools. I created one, extra for that. Okay, resampling time series data. Who has had like 6 types of data for the same place, the weather data, the energy data, and maybe 2 different meters, and all the timestamps were off? It's simple and silly, but you can throw all that data into a DeepSeek on your computer or put it on the web, and it'll resample all that and takes a couple-hour job and makes it like 2 minutes. So just amazing. Like the analysis. I can be at home now doing this work in hours. It used to take days or a week. Build regression models, Bayesian models, quantifies and visualizes uncertainty. And here's maybe another big one. Who's heard about Omniverse? So I can't see the audience or raise hands, but NVIDIA, and we all know NVIDIA is the underlying engine behind most of this, right? With their processors, GPUs. You can go here and look at all the various people that are building tools, including building energy tools. And let's see, building digital twins for smart cities, digital twins. So again, a lot of people are out there right now taking all the energy data, all the building data, building digital twins natively in NVIDIA Omniverse software. If you're not doing this yet, you'll be seeing it really soon. Amazing stuff.
Wait, Steve, can you tell us what a digital twin is?
Okay. Earlier, I pointed to building the Autodesk thing where Adam is building, taking Energy Plus or eQuest, Do2, and a physics-based set of algorithms which have been vetted by powers that be in ASHRAE that you can tune up to mimic your building. So you can use it to predict how much you'll save if you tweak some things, but you can also use it to run as a counterfactual. You update the model with the most recent weather, occupancy, or anything, hundreds of variables, and it will, if it can mimic in very, very close with accuracy to what the building's actually doing in real time in the future, that's good for 2 things. The main market for that right now, sales-wise, is for anomaly detection, fault detection. Is my thing operating as I expect it to? So there's a ton of people out there using digital twins. That's the general terminology for our industry, but again, everyone else, like NVIDIA, they're building digital twins on everything right now. So if you can mimic the characteristics and operation of a piece of equipment, a building, you can use it for fault detection, so if it's operating poorly, but if you can do that, you also have the counterfactual, and you can say what would have happened by just tweaking the inputs. So digital twin, it's going to be the best ever counterfactual, basically, the most trustworthy, if everyone's building it together. So this is the end of my part. I'm going to hand it off for the practical stuff now that Benedetto's doing. But the fact is, you can, I guess, hear my excitement about the possibilities this is opening up. I think it is really, really, truly like we're in a step change situation here in terms of availability of tools, but they're going to proliferate. Everyone's already got an AI tool out there. So you can't just say it's AI, it's great. You got to be able to explain it. It has to be auditable. All parties have to be able to run it and understand it, like my lawnmower. And it's a support tool that you develop trust in, not a decision maker. You don't just run it, let it go. It's going to give you some errors the first time. There's no question. It's like out of the gate, 60% great. You fine tune it a couple of times, you can get it closer. But I don't think ever you're going to want to run these things without human judgment, human people in the loop. So human judgment that we teach and explain through John, your great work keeping people informed through these webinars about what M&V is, and communicating across all the people in your food chain how these things work. I mean, I think it's going to be a gold rush for everyone on this call who already knows how MNV works generally to be explaining it to all the people that are going to be interested in this stuff in the future. Okay, how does it really work? So again, MNV is I like to call it now this quantitative numbers counterfactuals. What would have happened? How much? And it's an analysis that we do. And a lot of other people are doing the same thing because AI is making it practical, fast, and scalable. But your perspective out there, all you in this meeting, it's going to be the most important thing. How you take it, get your hands on the wheel, run the machinery, convince everyone else in your food chain that these tools are working in your favor. That's the end of my talk. Oh, just for fun, sorry, there's this glossary, and you can, if you're going to hand out these slides, John, this should be in there. Super good, you know, early, if you want to learn the real fundamentals of what we're talking about with quote unquote AI, really, really good set of resources here for people to do that. I'm done.
Okay, so now we're going to switch it over to Benedetto, right?
Yeah.
So while we're clicking around and getting confused, I want to ask you a question, Steve, or make a suggestion. I don't know if you have the time, but it sure would be cool if you could offer like little webinars or seminars, you know, maybe we even pay for it, how to use AI to do this, how to use AI. You know, you mentioned like 15 things that you could use it for. Well, I don't know how to use it to look at trend data, and I'd like you to show me how. Or I don't.
Yeah.
Or I don't know. You know, you had this regression tool. I want to see how do I get there? What do I do? That'd be really cool if you could offer something like that. You know, I'm sure people would pay for it. I'd pay to learn. So, let's
talk about that, John. I appreciate the thought, and I did think you're right. There's like, and again, all of you out there, if I show you how easy it is, you're going to be doing that it's going to be this network effect. So yeah, I'll be happy to unleash that, help unleash these powers that be, because I point to those. I only had 15 minutes, on this talk, but those tools take me minutes to actually develop rough working versions, and they may need an hour or two to get them working. Mm-hmm. Yeah, it's crazy. Go ahead, Benedetto. Yeah.
Great. Yeah. Yeah. Thank you very much, Steve, for the first part of this talk. I think it was really interesting to see your experience and your view on this, and how also to employ generative AI to like in MNV, in the MNV field, and many of these things I almost give for granted because I work with them daily, but I think it's really good to like take a step back and say, okay, like actually for people who don't know where to start, this is the basics, and it can do this, and this. Right. So I wanna connect to that. Maybe just a short overview of how I started working with the AI-powered measurement and verification. So as I said at the beginning, I did a PhD in this. I published a couple of articles. First, like just a review of what are the methods that are currently used, state-of-the-art methods for measurement and verification, analyzing stuff from Berkeley, for example, Lawrence Berkeley, where Stevie also worked, and many other labs that are doing state-of-the-art MNV. And then I also developed some new methods. And maybe just like a disclaimer would be that while Steve talked a lot about generative AI, what I am going to show you today is a different kind of AI. This is more what we usually call machine learning, and this is stuff that's been around for a longer time. It's been around since before ChatGPT came out, for example, and it's not, while Steve's examples of generative AI are mainly based on the analysis of text data, so natural language processing. What I am going to show you is more about the analysis of time series data. So applying artificial intelligence, if you want to call it so, or machine learning, how it used to be called before, on time series data, specifically the energy consumption of buildings, in order to basically calculate the counterfactuals, the adjusted baselines, and estimate savings. So from my experience in research, I then moved to Ento, which is the company where I work right now, and we have built all of this engine. We have built basically an energy management system for tertiary buildings, for commercial buildings, based where AI is first. So everything that goes in there is directly analyzed in an AI native environment. And then the last point that you can see here is this newsletter that I started more or less 1 year ago, where I do a lot of free articles to explain how to, well, first of all, the basics of MMV for those who want to learn also about that, but also like practical kind of tutorials where you can go through the whole workflow of applying machine learning to calculate, to estimate savings in tertiary buildings. So let's get into it. Well, first of all, maybe just an overview. Most of you will probably know this, but if we take a step back and say, okay, why is MMV important? Well, we can both accelerate the pace of decarbonization and reduce the total cost if we know which kind of projects are actually having the highest impact, because first of all, we can prioritize those projects, and second, we can unlock funding. We can unlock financing for the projects when we actually are able to correctly estimate or very accurately estimate with low uncertainty how many energy savings and then cost savings we are generating thanks to different energy efficiency projects. But the problem with this is that doesn't scale very fast, like traditional machine measurement and verification doesn't scale very fast. And this, like unlike the modern, let's say, the issues of our society right now, of civilization. So like climate change, if you're interested about that, is progressing very fast. We feel the heat waves. I think in every part of the world, and at the same time we are having like other kind of issues that are more like structural. So, for example, the grid. Here in Spain, we had like a blackout some months ago, and it was like really the first ever that I experienced like a day-long blackout, and this is all because we are ramping up electricity consumption due to electrification, but also to data centers deployment, and we are also ramping up renewables that are not that stable and easy to forecast, right? So renewables are intermittent, and the grid is really struggling for that. So we need a new set of solutions to deal with all these new issues that are arising. So at the company where I'm working on, we are right now dealing with managing more or less 40,000 buildings. These are just some of the people that are working with us, and it's just to give you an idea that we are working with large portfolios of buildings. So one of the issues here is, okay, traditional MMV is low and manual, and it can work for one building, but when you move to commercial buildings, you will know that most of them are managed in large portfolios, and when you are managing a portfolio of building, like these organizations that we are helping are, then it's really difficult to do MMV one by one with an Excel spreadsheet or something similar. So this is where AI shines. And I'm going to, well, no. Yeah, so this is where AI shines, because we are really able, thanks to AI, to do all of this way quicker. So first of all, we can integrate data from hundreds of buildings at the same time, because we can connect directly, for example, with utility companies. Then we can build scalable models. We can apply a single model that then can be at the same time deployed to calculate saving across thousands of buildings. And then those models can be used to verify savings very quickly. And a question that we usually get is at this point is, okay, but how do you actually access the data? Well, the data is there because utilities use this data to bill the customers, right? So they need to know how much they are consuming, and they need to know it hour by hour, and most of the time they will have smart metering or automated metering infrastructure. And then upon request, the utilities will have to share that data. I know that in the US it might be a little bit more difficult, and I even heard there's been lawsuits around how much utilities are willing to share. But I think that this is a trend that will only increase in some sense. So the amount of data that utilities are going to be obliged to share is only going to increase, and this is going to help us build more and more of these models and integrate in more buildings. The last advantage by integrating at the utility level is that you can get access to an entire portfolio. So while usually you could do MMV in a slow way by getting one CSV or one Excel, and then it probably stops at some point in the past, and then if you want updated data, you will have to request more data. Like here, you just get a seamless integration to the utility, and then you have live data that is updated every time that it is updated in the data warehouse of the utility that is building. And for all the hundreds of buildings of a certain data of a certain building owner. So that could be a public organization, could be the government, it could be private organizations such as retail or supermarket chains. Then once we have the data, the next question is how can we model the consumption? Well, what we learned, what the building energy modeling community learned after many years of working on this is that mainly commercial buildings consumption is driven by weather and occupancy. And weather is by now widely available via different API services, for example, and occupancy, while it might be a little bit more difficult to actually get, like the actual data about how many people are in the building at any given hour, usually in commercial buildings, they are highly correlated with what we can call calendar features. So what day of the week it is, what hour of the day it is, what week of the year it is. Then we can kind of approximate the schedules of this of the operations of these buildings thanks to these calendar features. Okay, then if I just told you we have the data and we have the models, and then the next question is, okay, does this unlock real-time measurement and verification at scale? So this is exactly what we try to do. A couple of years ago, actually, in Denmark, the Danish government told us we just implemented a few energy efficiency measures to mitigate the energy crisis after the invasion of Ukraine, and these were like switching off unnecessary lighting or lowering the set points and so on in all public buildings. And they say we would like to understand how much this saved. And so thanks to all this knowledge that we had and the data handling capabilities and the fact that in Denmark there is a data portal that allows you to access all this data seamlessly, then we just built this pipeline where we actually did option C, what we can call, when Steve will disagree, but let's say a whole building assessment, measurement and verification on these 9,000 buildings from the public organizations in Denmark. And I documented all of this in my newsletter, so that I will show you the links later. So if you're interested, there is like an overview of what we did, but also like some code so that you can understand better. These were the results that we found. Just like, I think one of the more interesting things is that it's true that the larger buildings will be usually responsible for a very large amount of savings, but we cannot neglect the small buildings because there's many more small buildings than large ones. And then if you are able to do something on many small ones, you will be able to get sizable, considerable savings. And then I also really like this figure with the portfolio savings, and where like the height of these bars is just the number of buildings that saved a certain amount, so 10%, 15%, etc.
Hey, Benedetto,
Yes.
sorry, I was muted on the last slide, but you mentioned about your newsletter. I just want to reinforce, get on his mailing list and get on his newsletter. I know everyone's overwhelmed with stuff, but he touches on so many issues that are beyond and globally, but adjacent and connected to everything we do, and it's really good. It's a really great newsletter, and I never read it in full because it's too big, but I always touch it and see what's the most important thing, and it's really worth having on getting in your inbox.
The easy way to find it is to go to his LinkedIn profile, and then I think under contacts it has it's under newsletter there. I think
He's an important player in this area right now, so it's really cool.
Thanks. Yeah, I think I have also a direct link at the end of the slides, and then if you'll share the slides, it will be there. And then I just wanted to show you, like, I just talked a lot, but maybe we can go through in 5 minutes and then leave 15 for questions. How this would look like in our, like, how all this work. This is actually like more or less 3 years of work that I summed up in this slide. How it will work in our platform. So, for example, if you go, I hope that you're, I think you're seeing my screen. So this is just like some anonymized data. So it's real data, but we are hiding who is actually owning it. And we have a list of energy efficiency projects that we are actually verifying. And then if you wanted to register a new one, you would go here, and then you just select, okay, I want to go on this administration building, and I know that I did some LED upgrades, for example. You can just choose when is the installation date, and then we'll just take care of the rest. That means we analyze the baseline data, detect the non-routine events, same thing in the reporting period, do all the smart things that you would have to do manually, and then come up with a relevant savings estimation that you can also dig into. So, for example, in this case, we can just open one of them. Here it was a supermarket where there was a missing signal between the BMS and the alarm system. It was causing a very high base load during the night that was not supposed to be there. And then when they fixed it, they managed to reduce the night consumption. And then we do our analysis that is especially interesting because compared to traditional regression-based methods that maybe you will work only at daily level, or you will work even at monthly level with aggregated degree days, you get very little visibility into when you are saving. And that is really interesting because, as I said, we are going into a very high share of renewables, and that just means that the volatility of prices is really high, and saving a kilowatt hour during the night is not the same as saving a kilowatt hour at 12 at noon. So, for example, in this case, we could just go in here and select, like zoom in and see when our model actually thinks that you're saving. This is just the typical IPMVP style figure where you get the adjusted baseline in green, and then you get the real consumption in blue, and then the difference is actually the savings, right, or the extra consumption. So we can see that after this project was implemented, so this actually, the alarm system was fixed. We were actually we are actually consuming a little bit more during the day, but we just get so many savings during the night that this brought like to almost 10,000 pounds savings per year in this site. You can also dig into this a little bit more if you are like this MMV geek. You can, for example, select what kind of features you would like. Like, this is the importance of features. So what Steve was just saying before about the interpretability of these models, you can try to understand here which variables are mainly driving the model and then the savings. And then if you think that there is a specific variable that you want to add or you want to exclude, you can also do that manually. And this could link easily with what Steve was saying before about being able to generate reports in an automated way using generative AI from this, right? So we could just plug this into one of Steve's tools and say, okay, just generate an MMB plan or a savings report based on all of this information. I think I'm gonna end here. I didn't have many more slides. Well, just something about the future of MMB, but Steve discussed a lot about it. Digital twins, really important. We'll get a lot of IoT deployed in buildings, Internet of Things, so that's going to be sensors that are going to allow us to just also include the comfort within the equation of measurement and verification. So we won't just be focusing on energy savings, but also on making sure that when we fix, for example, the operations of buildings, or we change operations of buildings, we take into account the occupants' comfort. And I think that's it. We are now open for questions. I hope it was interesting for everyone.
Great. So I think, Benedetto, you had 41 slides. I thought you were going to take longer, but that's great, actually. I think we have plenty of time for John to ask questions or the audience to ask questions. And I'd like to just, John, unless you have an immediate thing for Benedetto, I have again, a context I want to raise.
Yeah, context.
Okay, so and again, I hope people appreciate, I'm trying to give the big picture, and I'm trying to see the total landscape of the battlefield, or the what's that called, John? You're the battle, you know, what's the arena? The arena, right?
Oh, the arena.
Yeah, so the arena is big and broad, and there's a lot of little battles going on, and a lot of activities. And you know, you, John, I was trying to explain to my sister earlier, and I don't think I've ever told Benedetto this, but you know, you took over. I met you in Hawaii at Johnson Controls. Then you took over from Sonderegger and those guys the software that became Metrics. And you know, I guess I was along for the ride, watching Sonderegger in the ASHRAE meeting, saying what would be the right way to build the tools to do statistical analysis on monthly bills, right? Mm-hmm. So Metrics came out of that. And Benedetto, you're right. The John is a part of this whole higher legacy of people coming together to saying, what kind of tools can we use statistically to build regressions? What would be change points and things we need to look at within monthly bills? And John took that over and created the tool Metrics, ran the company, and still runs that and the Option C software. So, you know, in the US, and as part of the last 30 years, John's got a large part of that. And now Benedetto comes in and is taking it with the next set of tools a little bit further forward. With that having been said, and understanding how we all play together, you know, when we rewrote the CMVP materials, we said concepts and contexts. Concepts and context. That's also in my book. So the MNV professional. And Benedetto, so the context can be something like a performance contract where the parties are going to write a check at every reporting period. It could be a utility program where there's an incentive paid based on that quantified counterfactual. It's not just a nice thing to have a round number. It's like, this is the amount based on N amount. In performance contracting, you can have guarantees where, well, we're going to guarantee 80%. So as long as we meet some threshold, we're cool, right? No one gets too much short pencil because we're well within our safety zone. And but all of these represent different levels of articulation for your answer and confidence. So ultimately, counterfactuals, they're designed fit for purpose so that people have confidence to run their business. To that, I want to add Ento and then some other companies that do the energy management and the verification. They use these tools to say, see, it worked, right? But maybe Ento does it as a service, not as an actual settlement tool. So Benedetto, is that the case? Like your results are used as, okay, this demonstrates that it's working, but we're not going to write the check based on that. We're paying you based on the service you're providing. This just gives us comfort, basically. And that's different than, John, what you know in the performance contracting industry, where people need your tools to actually settle and pay checks and stuff. Mm-hmm. So riff on that.
Yeah, so I think we have both right now. We have most of our customers, of our users are actually organizations that have an internal energy management team, and they implement projects. So they are constantly trying to, first of all, fix operations. Like energy waste is just so large in many of these commercial buildings. Like you have so many systems where HVAC is going on at night, because when you are managing hundreds of buildings, it's really hard to be on top of each of them. So first of all, they want to know that whenever something comes up and we flag it into our management system, then when they think they fixed it, it's actually fixed. That's the first. Then they have some long-term decarbonization strategies, for example, installing a heat pump in place of a gas boiler. And these are also things that usually they want to get an insight into. So we thought before, with our engineering calculations, with our deemed savings estimation, that we would save 1 megawatt hour per year. But how much are we actually saving? So that is another use case. But we also have a lesser, I think, a lesser amount of our contracts are also with as an independent validator. So we have an organization that is actually implementing controllers and trying to save energy just on building operations, so no large energy retrofits. And then within that framework, they have an agreement between this organization and the final customer who owns the buildings, and then they tell us, hey, we would like you to add you within this, and we would like you to be in the independent validator of this energy savings that we are generating. So then, like, there is some level of trust from the final building owners that say, okay, we believe that whatever comes out of this tool will not be in the interest of any of us, and we believe that it is at the best, like, capability of what, like, technology and science can provide, right? But of course, as you always stress, it's like trust is so important in this field, and I think there is a level of trust that is related to the accuracy of the technology, and then there is a level of trust that is related to the human skills, the soft skills of the practitioners of this, and I think this is something that goes more in the direction of, for example, your trainings or the generative AI solutions that you showed before.
Yeah, that's great. Just because you're in Spain, I know you've been meeting with Antonio, and there's, I guess, this government, they're still trying pretty hard to put together certificates there, and you work with Watt Carbon. So again, this is another use case, right, where you're actually, you're stamping an approval on a certificate that's got value in the marketplace. So there's another value proposition, right? And what's going on in Spain on that? Are you familiar with that? Sorry, John, I'm just jumping in with questions of my own for Benedetto. If there's any questions from the group, are you?
Oh, I got a whole bunch of questions here.
Oh,
I got a lot.
Go for it. I mean, we're down to 5-10 minutes or so. Are you
Okay.
running? Yeah.
So number one, what underlying machine learning have you tested and recommended for those building digital twins?
I would go watch, if you want, Benedetto, if you have an answer, feel free. But Benedetto, I've had this, I'm still trying to get him over to physical models. So let's make this distinction. And as Benedetto mentioned, and I am not the authority, but no one is right now on how to talk about AI because it's changing too fast. Hence the title of my talk. Benedetto, do you agree? It's really hard to keep vocabulary straight because what's generative, what's reinforcement learning, what's RAG? I mean, I went to an AI conference a few months ago, and it was just mind-blowing. So among the things I learned, there's lots of different parties taking simulation engines of any type, supply chain simulation engines, sales simulation engine models, and trying to calibrate them with all the data they can collect within that domain, whatever they're doing. So there's lots of data sources and a simulation model of the procedure, whatever it is. And then there's a bunch of AI tools that are trying to train that. Not large language models. These are analytical generative AI with data and code. So when you take that and you put it over to that one side I showed you with the Autodesk, that's the most relevant to us. And that talk I pointed to, you can see it with Adam, Set Metrics guy down in Australia, who's taken it the furthest that I've seen. And I watched that and I thought that guy's doing exactly what I would do if I had a team and the time, in terms of starting with a rough Energy Plus model. And I used to talk about an ingot that you'd start with, and you'd bang it a few times, and after you hit it a few times, it would look just like the real building. And that's what
Steve, I was doing this 25 years ago at Silicon Energy, believe it or not.
You know, with Sandra, yeah. Well, it's now at the process between.
Now it's automatic. I know, but no, I had an automatic procedure, and it's through corporate mismanagement we didn't get it built, but I had procedure to do that.
Yeah, to answer your question, I think that set metrics is the thing, SET, and Atom, and that if they get these slides, they can go back to that Autodesk talk, and that's the best I've seen. I'm trying to stay in touch with Tianzhen Hong at LBL, with Adrian Chong in Singapore, and everyone in the world who's talking about this. It's another channel that's a fire hose, right? All I know, I can tell you, it's a fire hose. You can point yourself to it, and you're going to get knocked over with the amount of information.
This guy Adam in Australia, how do we get a hold of, or he has a website and we can go to his website and we can find his model or something?
Look at that talk. That's the first place, but it's through a strange connection to other people I know. I know people that worked with him years ago and helped when they were trying to get a workflow around Energy Plus. They were working together on that. So yeah, I don't know. I haven't met him directly. I've actually got a call out to him right now to try and meet. But yeah, we can find his website or go to the Autodesk University and ask for that, and then Google or search within that site for building simulation. Tandem.
Oh, okay.
Yeah.
Okay, that's good. Okay, here's another one. Can you link? Can you share the site Steve was presenting? So maybe an email later with just a list of all these sites or something. Is that possible?
Pull the links out.
Yeah, that'd be really cool.
I have a website too, Counterfactual-Designs.
Yeah.
And go there, and it's stupidly because I've just matched it up because I'm not a good designer. But all my links are in there, and so I can have easy access to them. You can go to that site right now and find most of those, if not all of them.
Okay. Here's now. Do you have any available reference or project information or a report where we can learn more about these AI-enabled digital twins, M&V application features, etc.?
Same thing. That's basically the same question, I think, John. And I'd say, within M&V, it's not a lot per se. It's sitting there waiting to be grabbed, but they're not talking about M&V yet.
Okay.
I mean, it's an M&V tool. That's what I'm trying to say. You have a quantitative counterfactual if you can build a digital twin. It should be trustworthy.
Now, maybe I don't understand this term, or maybe I do. Is there any story behind the IPMVP options pushback references?
Is that maybe for me and my pushback?
Yeah, it's for you. Yeah.
I don't want to go into that in detail. Maybe I think, John, when we did the original,
we talked about this earlier because you wanted a separate option, which was option 0 or something like that, right?
We did a talk. People can look it up. You can just Google or use chat and say, "Did Steve and John talk about original sin?" And that hour-long webinar. It gets back to what I just said. The protocols are great. They were written by a committee at a time with a specific use case, which was the federal government. And we basically came up with, do you do a measurement boundary of the whole facility or point at the thing? Do you just measure short-term performance measurement, or do you measure continuously of the thing or the full building? And later, can you build a physical model, a full physical simulation model? And there's, we introduced this whole counterfactual thing, not calling it counterfactual then. I just believe there's a better way to construe the set of options we have with the tools we have now. And the old option terminology, I think, is really limited.
I've got one. And so what you said, Steve, I kind of, I think you're right for a while. Yeah, sure. Good M&V is going to require human intervention. But you've seen the movie Terminator 2, haven't you?
No. I don't.
I think everybody else who's on this call has seen it, and I don't think there were any human bad guys because the machines had taken over. Now, I'm not saying that the machines, the AI is going to take over per se, but I'm saying that companies may just have an M&V engine, and at some point, it might be 10 years from now, it might be 5, they're just going to say, yeah, we don't need you, like to do RFP responses. Oh, it's automatic now. It's automatic. We have all of our old RFPs. The AI's read our old RFPs. It read what it needs to do and it went and just did everything. And we don't need any human intervention. It just happens.
Okay, so to that, I would say maybe because, but let me say where we are right now. This is August 13th, 2025. I'm on a bike ride this weekend. I'm talking to someone after the ride. She's a lawyer. She's been using all these tools in her practice, and she said, and we're just we were just going back and forth. Like she goes, it's so amazing. Like we're getting all pumped up. There's so many things I can do so much faster, but I can't let them loose with my junior staff. No. I've got a product. I've got to have my hands on the wheel. I can give them training wheels. I can get a ton done really quick. I have it to throw it over the desk and I have to give the last look, or else they'll say that's something wrong, and it can't be wrong. So it's the difference between production quality and pretty darn good. And we can all get to pretty darn good really fast now. But when you say, execute on command type thing, machine doing it, when the final trust is built and these things actually work, I don't think we're there. We're not there now. In 2, 3, 5 years under some simple things, maybe, getting back to blockchain and smart contracts that could actually execute based on these things. You'll probably see examples of that. It's probably happening right now. But yeah,
I was just this morning was looking on X, and this guy posted a commercial for some liquor that was done by AI. He said, and they say the cost is about $20, and it cost $1 million to do an equivalent commercial, if humans did it. I mean, that's it. I mean, I'm sorry. That's going to be happening with our M&V reports when they start getting these. Let's say they wanted to go with option C, and they're getting these feeds of utility bills. They're getting feeds of utility data. They can identify non-routine adjustments. They can identify them using that IPMVP M&V guide. You can identify, or the non-routine adjustment guide, you can identify non-routine events, and you could actually create the mini models or whatever method you're going to use. It could do all of that. You don't need a person. That's common.
So Benedetto is probably going to want to answer that in terms of the non-routine events, and I let him, but I still think you need humans on the ground, boots on the ground, to double verify what they're seeing in the data at the whole building level. But that's another whole seminar, John. We could come back.
Mm-hmm. Go. Did you want to jump in on that, Benedetto?
Yeah, I think in the end, what we're doing here when implementing more and more AI is just we are allowing humans to execute more projects and to dedicate the required amount of attention to each project. So if before, like for example, I'm making the example of our app because it's the first-hand experience that I have with this work. But like if they had to sit down and do in Excel or a Google Sheet regression, download the CSV from their utility, upload it to Google Sheet, and write an Excel formula to get a linear regression on top of that, and maybe do some plots. They would just either not do it, or they would basically do one per day, or a couple per week.
It take a long time.
Yeah, with this, like you can dedicate the time to actually go in the building and do the things, or develop your social relationship with the customers or with the technicians, so that you can actually implement more projects in those buildings, and just leave the slow and repetitive tasks that computers can do very well to computers.
Okay, so I'm going to disagree with you. I mean, what you said, I agree with everything you said, but the future you're talking about depends on management, and you're assuming management's going to still use the same number of person hours to get this work done. And I would say as soon as AI has been proven, they will start cutting back. And there will be less people, and we will get the same level of service, and we won't have the people walking around. And what I see coming is that there won't be any more junior engineers, that there won't be, there will not be a next generation of M&V people. There will be some of us who are really good at M&V, who are going to be doing all the work, and the people who are kind of mediocre at M&V, they might not have jobs in 5 years. Okay. And then the people who are new, they are not going to be able to learn how to do anything because the machines can do all the low-level work.
All right, I'm going to push back on that, because I think Benedetto and I also, but by the way, let's go back and define M&V from my perspective, and then Benedetto's and yours, John. And remember, when I'm talking about it, I'm talking about the full range. Sometimes people go and they do retrofit isolation. Sometimes you have to get inside the building and decide where you're going to hang the meter. Sometimes you got to put flow meters on, and there's a whole different world of M&V that could be a separate seminar, I guess, because we're talking to two people, you and Benedetto, John, that do analysis at the statistical level, at the whole building level, primarily. So just remember, if you're out there listening and you're a field person, your skills are really valuable to be able to go into a site, really know if that's a two-way valve or a three-way valve, what's happening, and you know that, John, because you're an auditor. Okay, there's that. If you can go take Benedetto's tool or any one of these tools and come to the U.S. and hit 10,000 buildings and start doing them, 200 or 300 are going to need extra attention right away to see what's really going on. Everyone on this call is going to have a job to go out and do the extra work. It's going to expand the work we do. There's so much work that could be being done right now that's not, because people aren't seeing it. So there's that waste, right? But when we start seeing all the stuff that's not happening, we're going to need skilled people to go out, fix those valves, tune those things, tune the controls. There's a lot more work. I'm sure of it. I'm sure of it.
I work for an ESCO. I mean, it's one of my clients, and I'm doing, I don't know, maybe 13 or 15 M&V jobs, right? They did a lot of controls, scheduling, setbacks, etc. And there's one or two clients that the controls are still working. They're still scheduled. They're still, economizers actually even work, believe it or not. But the other 14 or 13 or whatever, no, they don't. Every year we point out, look, this is broken. You didn't schedule. You need to reschedule all these things. You're not getting all the savings you can get. They know. None of them fix it. It just doesn't happen. And we say, look, we'll help you. You're going to save all this extra money if you fix this stuff. And the payback's going to be less than a year. Just schedule stuff. Nothing. Year after year after year. That's reality.
Sorry. Yeah, you're probably right.
Sorry, I didn't mean to be so negative.
Trying to be optimistic. You're probably right.
So if I'm right, to those who are listening, look, I'm not saying leave M&V because there's nowhere to go except for becoming an electrician or a plumber or a nursing assistant. But what I'm saying is become the best, become better than everyone around you, because that's the only way you're going to maintain a job.
Well, jump in the pool now too, and open up Replit or go look at Vercel and start playing with it, because you'll learn how to drive these really advanced machines really quickly, and you'll become. You have a chance to ride that wave. Everyone right now, anyone in the world can open up Replit in any continent, on Starlink, and be an expert pretty quick, or be pretty good pretty quick. I still think, John, it's going to expand the application because there's going to be so much easier access for so many more people. But I'll stop.
I hope so. Okay, so let's move on to the next question. This was a question about the real-time solar irradiance, GHI. Where do you get that? Is there a place to get that?
Yeah, so we use a paid service for our app, which is called Visual Crossing, but there are many free resources for GHI. I think NREL has one.
Okay.
Maybe I can find the link and put it up in the chat.
Yeah. So maybe, well, you guys are going to give me a set of links anyway and so maybe we can add that on there. That'd be nice. Here's one. It's very good to know about AI automation for analysis and data collection. Anything on agentic AI for the M&V industry? Well, that's an interesting question.
This is the generative side as well, I think, but it's just the power of these tools is that they can go now, and whether it's model control protocol, MCP, and again, the language is changing on this, but you can give them tasks and they go out and do them, and they go access, you can set it up to access that in real time, that NREL website and come back with the data. So you set up a tool that says, when I need it, I know how to go get the data and bring it back to my model. It doesn't just build a regression model, but knows where to find the data. You can have agents, you can build agents right now in Replit that can do that. And Replit can be free or pay $20 a month. And insane, it's like getting a bulldozer when you're used to having a shovel. It's like suddenly you got to learn how to drive the bulldozer, but try it. Please, people, just go try it. Just go REPLIT.
Okay.
Free or $20 a month, and just start playing. If you're not blown away, send me $10 if you think it's worth it.
How about you send us $10 if you think it's no good?
Yeah, I'll pay you 10 if you don't think it's no good. 20 if you do. It doesn't change your life.
Yeah, right. Okay. And the Ento tool, is that proprietary or is it publicly available?
Yeah, that's proprietary, but I do have on my newsletter on Substack, I have a few tutorials with that are free, and there is the exact code with which you can replicate most of what you see on the proprietary page. So you can go follow up those up, have an LLM, have an AI explain what's going on there to you if you don't understand first time.
Okay, here's one. In a high-level range, in your opinion or experience, how much is this AI-driven M&V approach? How much will it reduce traditional M&V costs to do the same or similar scopes? Yeah, that was a question I was asking. So you were saying initially you didn't think M&V costs are going to go down at all. We're just going to do better work. And
no, I didn't.
How much do you think M&V costs will go down?
I said a lot more people are going to be doing it because the cost. It's like if the cost goes down, a lot more people are going to buy it.
Yeah,
So,
yeah, because maybe it's not even because now maybe even contractors will do it. Guys are putting light retrofits. Maybe they'll start.
Grouch. Okay, Mr. Grouch. Sure. No, it's going to have both. I think there's going to be a lot more of it because it's easy and fast, and everyone's going to understand it better. If you remember, John, like my one of my angles or my in my life and my framing of this is to create this cadre of professionals. The CMVP is the channel I've got right now, and the CMVP I want them on all sides of all deals. I want every organization to have one so they know, as Benedetto said, they're getting everything they can out of the deal, and that the M&V is the design of the counterfactual is structured properly, fit for purpose for their job. So again, whether it's quote unquote option B, a measurement of a subsystem, or option C, hourly, monthly, daily, or hourly, or sub-hourly, or sub-minute, whatever, they can come up with those solutions together. That's the best thing. Why did I go there? I just think if everyone understands it and they get together, here's the thing. This the lawyer woman I talked to about how she's using it. She goes, it's one of her most important use cases is getting a client online and opening up ChatGPT and asking questions coincidentally at the same time and seeing what the results are, discussing it. And they both, this is like prompt engineering in real time. And it gets you to yes really fast when both parties can have a tool that says, well, let's go quickly show you what regression is. One of the biggest impediments of getting to yes in M&V, because our product is invisible, it's really hard to trust, is words.
They don't understand it. It's concepts, yeah.
Yeah, and so if you can have people get through those barriers to where, okay, now we understand what we're talking about, we understand what data we're going to need, we know the costs, I'm willing to do it. I understand this whole thing now. So I think that there's, in all these ways I showed, whether the M&V planning, the reviewing of M&V requirements, go take an old IPMVP and dump it into chat and say, show me how this works. And is it inconsistent or does it have problems at all? Sorry, guys. There's inconsistencies in the names of in how the options are defined across time and within the document. That's an impediment. It causes confusion. And that's back to the original sin, what those documents are used for. They're supposed to be guidance documents. So we're supposed to be going out and developing fit-for-purpose, custom-made, counterfactual designs for each project. But it's fast now because these tools allow it to be fast.
All right, so let's go on to the next question. Lantong, there will be a video recording. Just email us at webinars@abraxasenergy.com and we will send you a link. Short term, this person says, AI will increase productivity. Long term, AI will replace M&V professionals. Anytime people say it won't replace jobs, it sounds disingenuous. I'm with John here. I completely agree. That's just one man. I mean, just because two of us say that.
Perspective. I just don't think so. We'll see. I think there's going to be more work.
There will be for you, but there will be for you. The question is, what about for the person that's, just learning? That's the question.
I'm going to try, everything I'm going to do in my career is going to be towards creating a world where M&V is desired because it's so fast, easy, and understandable. And they're going to be wanting to open up the book and find a local resource who can make the professional stamp on it. That's my goal, is to make it bigger, make it easier, make it less confusing, less boutique. That's also why I want to link to other industries and show we're doing the same thing as everyone else who measures interventions. We can be using the same tools. We can be learning from them, sharing guidance, hiring their grad students. I mean, this is all cross-platform. We're doing the same exact thing as so many other industries right now. So if we isolate ourselves and call it, we do M&V, it's going to harm us. If we say we're doing the same quantitative counterfactuals as hundreds of other industries right now, can we learn and share experience? That's going to help us communicate what we do. I really think that we limit ourselves and we just say M&V is some boutique thing.
Okay, here's one, another comment. Michael says that he's commenting about me and these guys not fixing their buildings. Remember I mentioned that I told them all the problems, they won't fix them. He said energy prices aren't high enough yet to fix those other buildings. Yeah, he's probably right. But see, the other thing is, though, these are public entities and they're not for profit. They get the money no matter what. And I think that's also part of the deal.
Yeah.
Let's see. Marcus said that NOAA and NREL are delayed by months. Oh, he's probably talking about. Yeah, that's it. That's all I got for questions. You guys want to add anything else? Any last words? I want to, before you do that, Steve, let's talk about this one more time. I mean, look, you can't commit. You got to think about this, but I think it would be really cool if that list of all those things, not all of them, I mean, how to respond to RFPs, we can figure that out ourselves. But some of that stuff you listed, that would be so neat if you could show us step by step how to do it in a webinar where we pay, we'll pay $50 or $25, make it kind of cheap so that, everybody can expense it on their credit card. You'll make a little bit of money, but, you're not going to be a millionaire, but you make a little bit, but you really, that'll do it.
Just do it. Really. I'm on, John. I'll come down and we'll talk about it.
Okay.
Yeah.
Okay. Any last words?
Thanks to Benedetto a ton. He's the future of this, John. So
thank you, Ben.
Yeah, thank you, man. And it's great. Yeah. Thank you, John, for having this this meeting.
I think like if you're afraid of about like AI taking your job, like it won't take your job if you just like keep honing your craft, keep like getting better every day, thinking a lot about what you're doing, not just using tools mindlessly. Like there is a lot of space in the future for people who are actually like, for people who give a shit, for people who are actually willing to put the time there and like go to the bottom of the problems and solve them. And these people are those who are going to harness the tools to get incredible things done. And if you stay back in the low percentile of those who don't care, who don't give a shit, then yes, I think your job might be in trouble.
The other thing I would say, I'm going to add to that. So that's one way. I assume you're more of an intellectual because you got a PhD than some other folks might be. And for those who are less intellectual, let's say less math inclined, but in the M&V industry, I would think the best thing you can do is, especially if you work for an ESCO like Honeywell, Johnson, or Siemens or whatever, is take controls classes. Learn as much as you can about controls and about the devices and the systems and how things work so that you can be that guy or that person that goes into the building and finds the problems. I mean, I think that people who know retro commissioning will if you know retro commissioning and M&V together, I think you've got a future. But just do more hands-on work. That is, I think, what it takes. But if you're just a desk person, I think you've got less of a shot. That's just my thought. But I don't know. I mean, just my thinking.
Agree. I think we all agree.
We'll know more in a year what AI brings us next. I think there's waves, and if you surf every wave, you'll be good. Just get up on top of it and find the latest technology and stay on top.
Okay, yeah. And one last thought is that for some of you that are planning on having babies, please make them watch Terminator 2 young and impress upon them that they need to be the next John Connor. That's my suggestion.
That's my evening.
Okay. All right. Thanks, everyone.
Thank you, man. Take care.
Bye,
everybody.